everyone, I am Mario Lape, and today we will discuss about stresses in thin-walled pressured vessels under the topic transformations of stress and strain. So let's define first what is shear stress, since we will undergo about a problem later on about shear stress. So mathematically, the resistant force by the body acting per unit of area is defined as the shear stress. It deforms a particle or an object without changing the volume of the body. So without further ado, let's get started to our given problem. So our problem states that when the filled to capacity, the unpressurized storage tank shown contains water to a height of 14.6 meters above its base. Knowing that the lower portion of the tank has a wall thickness of 16 millimeters, determine the maximum normal stress and the maximum shearing stress in the tank. Take note that the density of water is 1,000 kg per cubic meters. So first, we will gonna calculate the maximum pressure, which is P max is equal to specific weight times water height. So 1,000 kg per cubic meters multiplied by 14.6 meters is 14,600 kg per meter squared. So we're gonna convert kilogram per meter squared into pounds per inch squared. So it is 20.766 or 20.77 pound per inch squared. Then we convert again to PSI. Since 1 pound per inch squared is equal to 1 PSI, then we have 20.77 PSI for the maximum pressure. Next is we solve for the inner radius. With a given formula, 1/2 diameter minus thickness of the wall. So 1/2 times 7.5 meters times 39.37 minus 16 millimeters times 0.0394. Take note that these values are the conversions to inches. Then we have 147.007 inches. Then we have a given formula of the hoop stress. Sigma sub 1 is equals to P times R over T. The P is the pressure, the R is the inner radius, and the T is the thickness of the wall. Then we have 20.77 multiplied by 147.007 over 0.6304. So it equals to 4.84 times 10 PSI. Since the principal stresses sigma sub 1 and sigma sub 2 are equal, then we have 4.84 times 3 times 10 to the power of 3 PSI or 4.84 KSI for the maximum normal stress. For the maximum shear stress, we have then this formula. The shear stress max is equals to 1/2 sigma sub 1. So it's 1/2 times 4.84 KSI. Then it is 2.42 KSI for the maximum shear stress. So our value for the maximum normal stress is 4.84 KSI, and for the maximum shear stress is 2.42 KSI. That's all. Thank you.